Alright, next up, let's proceed to cosine function. So we're done with the sine function. Let's proceed now to a cosine function. So the parent function of a cosine function is given as y equal to cosine x. Okay, so the graph of a cosine function actually looks like this. Okay, it's like a V-ish or U-ish shape. Okay, so but of course we know that since it is a wave, it's going to be continuous because it is periodic. But for one period of a cosine function, this is how the graph would look like. Okay, so in this case, our amplitude is 1, our period is 2 pi, our phase shift none, vertical shift also none. So this is our parent function. So our amplitude is simply 1. So we know that with the sine function we start here at the origin. Okay, but if it is a cosine function, we start at the highest point. So we know the amplitude is 1, so we start here at 1. Okay, but before we continue on with our wavy graph, of course we are considering the period, which is 2 pi, and same as with what we did with the sine function, we need to divide this segment into 4 partitions. So 1, 2, 3, 4. Okay, so again, half of a pi is pi over 2, and then pi plus pi over 2 will give us 3 pi over 2. Okay, or if you just want to count, 1 pi over 2, 2 pi over 2, 3 pi over 2, and then 4 pi over 2. Okay, so next, we don't start at the origin, we start at the highest point, knowing that our amplitude is 1. So let's go to the next point, which is on the central line, the x-axis. Okay, next, we go down to our throw 1 unit from the central line, and then we go back up again on the central line, and then reach again our peak, which is 1 unit from the central line, so that our graph will look like this. So let's connect the dots. So one period of a cosine function looks like this. Alright, so after knowing the properties, the transformations that we will do on this function, let's start graphing. So the first things we need to consider, of course, the amplitude and the period. And take note, it's -3, so there will be a reflection across the central line. But before we do that, let's take note of the period first. So we know that our period now is pi. So instead of having a thick, if I may say, a thick graph until 2 pi, it's just gonna be slimmer. It's gonna be slimmer because from the y-axis, all we need to do is reach pi and we're done. We have completed a period already. So that will look very, very thin, right? So, of course, we consider the amplitude also, which is 3. So that must be 3 units away from the central line. In this case, let's consider our central line being the x-axis. Okay, so we will do the horizontal shifting or the phase shift and the vertical shifting later on. But first, let's have this. First, we need to divide the segment into 4 parts. So that's 2 parts. And then divide the 2 parts into 2 again. So we have now 4 partitions of that segment. And then we know that the amplitude is 3, and we're going to start plotting the point on the y-axis. So we are expecting it to be here. But since we know that it is negative, we have to reflect it. So instead of plotting the first point here, coming from the peak, from the highest point, we're not going to do that because of the negative sign. We will reflect the graph. So we're going to start plotting a point here at -3. Next, let's go to the next partition, which is this one. Okay, from this point, we go to the next partition and we plot a point on there. Alright, and then after this point, we need to go up to the peak, which is 3 units away from the central line, and that point should be parallel now to this partition. So from this point, going up here. Okay, so that's how you do it. Next, from the peak, we need to go back to the central line. So from here, go back there. From here, go back here on the central line to the next partition. Okay, then lastly, go back to the throw, parallel to this point, 3 units away from the central line, and it is parallel to pi. Okay, so that is the last point that we need to plot so we could complete one period of this function. Okay, I think it's not parallel enough. Let's move it a bit here. Okay, good. Alright, now let's start connecting the dots. Okay, so it looks like that. It's very slim, it's very steep. So that's how the graph of -3 cosine 2x looks like. But we still have a phase shift and a vertical shift. So let's do that next. We need to move. Okay, as you can see, I made the previous graph a trace graph because I plan to make the final graph the solid graph. And before we do the phase shift and the vertical shift, I have a zoom in Cartesian plane right here. So this is the origin. We have here until pi, and at the other side is until -pi. So if we're gonna zoom it in, these 4 partitions right here have these coordinates. Okay, so this is pi over 4, which is that one. The next is pi over 2. This is 3 pi over 4, and this is pi. Same thing goes here. If we divide this segment into 4 partitions, this is -pi over 4, -3 pi over -pi over 2, -3 pi over 4, and -4 pi over 4. Okay, so I was able to get these coordinates even if it's not written here. Basically, you just consider it like a pi. Okay, so you have 1 whole pi here divided by 2. You divide the pi by 2, and then divide another part of it, so you have 1/4 here, 1/4 of a pi. And then if you have your third partition here, then it's going to be 3/4 of your pi. So that's how you identify these coordinates. Okay, so now we know that our phase shift is pi unit to the left, because this is plus. Alright, so I made this zoom in a Cartesian plane so we could know how will we do that kind of phase shift, having that we have this kind of graph. How will we move this point to the other, up to what point? So let's say we have a point here at pi over 4. Alright, so for me to move such point pi unit to the right, meaning if you can see, 1 whole pi is equivalent to 4 partitions, right? It's equivalent to to 4 partitions of that segment. So if I were to move this point pi unit to the left, meaning I have to cover 4 partitions also. So this is the first partition, second partition, third partition, and then the fourth partition. So if I were to move this point, I have to move it until here. Okay, so from pi over 4, I need to cover 4 partitions for me to move it pi unit to the left. So first partition, second partition, third, and then fourth. So I will stop there. Okay, so that's how I horizontally shift this point at pi over 4. So let's apply the same concept here in our graph. So let's first have this point right here. So I need to move it pi unit to the left, so it has to reach until -5. So I'm able to cover the entire thing. And obviously, since you are on the y-axis, to move it pi unit to the left, of course, you will eventually reach pi. And then, next, let's consider this point on the central line. We will move it pi unit to the left, so we need to cover 4 partitions. 1, 2, 3, and this is the 4th. So you need to move this point here. Okay, next, let's have the peak of the graph. So move it pi unit to the left. So from here, 1, 2, 3, 4. So it must reach until this coordinate. Okay, and then this point on the central line, 1, 2, 3, 4. Okay, and then lastly, the point at the throw, it has to move pi unit to the left. So 1, 2, 3, and then, wait, I missed it. 1, 2, 3, 4. So you will reach until here, right? From here to here. And of course, this is the point parallel to pi, so if you're going to move it pi unit to the left, you will reach the y-axis. Makes sense? And then after doing such, let us do vertical shifting. But if for visualization's sake, let's graph this one first. Okay, so this is how the graph looks like when it is horizontally shifted to the left, pi unit to the left. Okay, so if we have this one at pi over 2, of course, pi over 2 minus pi, it'll give us -pi over 2. So this point will shift right here, parallel to -pi over 2. And then next, this point on the central line, it is it is 3 pi over 4. So 3 pi over 4 minus pi will give us -pi over 4, which is right here. And lastly, this point parallel to pi. Okay, so it's going to be pi minus pi, so it's 0. That's why we are here on the y-axis. Alright, so since we're done with the phase shift, let's do the final step, which is the vertical shift. So I made a previous graph, a trace graph, of course, and then the final graph will be the solid graph. So since we're going to move 1 unit down, because this is negative, so same thing as what we did with the sine function. Our central line here previously was the x-axis, but since we have a vertical shift, that central line will move 1 unit down, and so it will urge the other points also of our graph to move 1 unit down. So we'll have a new central line here at y equals -1. Alright, so that will make, of course, all the other points of this graph move 1 unit down. So let's move Let's move them. Let's move these points 1 unit down. And then from here, 1 unit down, 1 unit down, 1 unit down. And then we're done. I think I need to draw the final graph, but I need to remove the trace graph because I think they're gonna overlap. So since we're done doing the plotting the key points that we need, let's remove the trace graph already. Okay, so I'm done erasing the trace graph. Now let's connect the dots of our final graph. And we are done. My graph is, of course, it's always ugly, but I hope you get what I mean by this. You understood how to graph it by doing it step by step. I know this one is really hard. I'm not sure if you're really comprehending what I'm saying right now, but I hope this video that I've made would help. But before I end this video, of course, if we do reflection with a sine function, let's consider also what if this becomes positive. So we know that will be a reflection of this graph across the central line that we have now, which is y equal to -1. So we need to do the reflection thingy. So from the central line, the amplitude is 3 units. Okay, so we know that if the leading coefficient here is positive, the graph should be looking like this. Okay, this is for positive, but if it is negative, it will look like this, just like this graph. Mali. Just like this graph. Yeah, if it is negative. Okay, so since I am considering what if this is positive, so we need to reflect this graph over the central line. So from the central line, 3 units up, 1, 2, 3. We start with the highest point and then we go back to the central line, okay, which is here, and then we go down again to the lowest point, which is 3 units also from the central line. So that is 1, 2, 3. So that would be here. This is where our throw is, and then go back to the central line here. Sorry. This is our new central line. Okay, so go back here in the central line and then go back up to the peak, 3 units from the central line. So that is 1, 2, 3. So here. Okay, so I'm gonna make it a trace graph. And so this graph, this trace graph, is a reflection of the function we graphed earlier, which is this one. Reflect across the central line. I hope you got something or learned something from this videos. I'm a beginner. I am not really into this kind of teaching strategy, but I hope that it would help you. I hope that as your teacher, I'm able to reach out a hand to you. So please do your best during this quarantine. I will do my best also to teach you using my best abilities, just to reach out to you and help you with your learning. I know it's not easy, but let's keep the faith. God bless.